It says that gadgets are produced in a perfectly competitive, constant cost industry. It gives each firm's cost function, the demand for gadgets, and then it tells us, suppose a tax of $2.38 per gadget is levied on sales of gadgets. Based on the long-run industry supply curve, what is the deadweight loss created by the tax? So first of all, we know that this is in the long run. It told us based on the long run industry supply curve. So we're going to be able to use this relationship, which is price is equal to marginal cost, which is equal to average cost, to solve. We know that marginal cost is 3.6. We know that average cost is total cost divided by quantity. In this case, 31 doesn't have a Q with it, so we don't want to go ahead and divide through everything by Q because it's going to make it a little nastier. Instead, we want to go ahead and equate those right off the bat, and now we can multiply each side by Q to get rid of it on the right side. So we do that, and the left side becomes 3.6 Q squared, and now on the right side, we've gotten rid of that Q in the denominator. And now we can solve for Q. We do this, and we see that Q squared is 17.222, so Q is equal to 4.15. Well, we know that Q is 4.15, so we can find price, because price is just equal to marginal cost. So we plug in 4.15 into our marginal cost, and we find that price is equal to 14.94. So we can find quantity demanded, we can find the equilibrium quantity before the tax. So we haven't talked about the tax at all yet. We're just going to find what the initial equilibrium quantity is. So we plug in our price, and we see that our initial equilibrium quantity with no tax is equal to 6,792.9. Well, that's the quantity with no tax. How will we find the quantity with the tax? Well, we know that price plus the tax is equal to 17.32 because we know that price was 14.94, and in this case they just told us there's a constant tax of 2.38 per every unit. So we can just add that to get 17.32. Now we can find out what our new quantity demanded is with the tax. So we plug in 17.32 for the price, and we solve that Q with the tax is equal to 6,440.64. So now we can solve for the deadweight loss. It's just going to be 1/2 base times height, where the base is the change in quantity. And here we see the change in quantity is 352.26. And again, that deadweight loss is 1/2 base times height. The height of that triangle is the height of the tax. So we have 1/2 times 352.26 times 2.38. So real quick, let's take a look at a graph of what this looks like. So we solved for the deadweight loss to be 419, but let's look at a graph to see what exactly we did. Well, we had P star and Q star before the tax, and then we increased our price by that vertical difference between Q star and P star and PT, I'll call it, so price after tax. And we see that that resulted in us decreasing our quantity from Q star to QT. So this red area right here, this is the amount that we calculated. So maybe you'll have to find this on a graph, or you'll have to recreate this graph, and you want to be able to do that. So this is the deadweight loss that we calculated. Again, it was 1/2 times base times height, where the base was the difference between Q star and QT, and the height was the amount of the tax, which is the difference between P star and PT.